Hi folks, so what we're going to do here is a question from the 2025 Leaving Cert section B question 2, and this question here specifically comes around the topic of oblique plane and intersecting planes. So it says here, figure B2, the image on the right shows an indoor adventure centre in Abu Dhabi. The building includes a series of intersecting planar triangular surfaces, which is all these surfaces on the structure. Figure B2 below shows the plan and elevation of 3 intersecting planar surfaces. So what they're doing is they're taking, I think it's this surface and this one, and they've drawn the elevation and plan view of them, and they've provided our coordinates here. The horizontal and vertical coordinates for the points A, B, C, D and E are given. So part A of the question, it'll always ask you this: draw the given elevation and plan of the intersecting planes ABC, BCD and CDE. Okay, so step 1, that's what we're going to do. Now what we need to know from these measurements here is for point A, what that means is the first measurement is the measurement in, the next measurement is the measurement up, and the next measurement is the measurement down from the XY line. So it goes in, up from the XY line, down from the XY line. And we can clearly see A is actually on the ground because it has a height of 0. Whereas point B is up 20, point C is up 40, D is up 70, and so on. Okay, so we're going to plot all those coordinates now. So in the middle of your page, you've got an A3 page set up here. On the day of your exam, you'll be using an an A2 page. But I'm just going to start off with a light line because I need that line to measure my coordinates on. So starting off by doing my coordinates, I'm going to pick a start point. My start point is going to be here. That's going to be my start point. Now the first measurement I'm actually going to do for all of these, so I can be accurate, is actually all of these guys here: 160, 130, 200, 110 and 190. Okay, I'm actually going to plot all of those measurements first, and then I'll do the various up and down ones from the XY line. Okay, so I'm going to start with those there first. So starting off with my 0 at my start point here, my very first measurement is actually point letter D, which is 110, so it's 11 centimeters. My next one after that is B, which is 130. Next one after that, after the 130, I have is 160, which is A. Next one after that is 190, and then 200. So there's my little marks, as you can see them. Now what I'm going to do is I'm going to plot the actual increments. So starting with point A, actually I'll start with the lowest one, which is the D, which is the very first one. So it's up 70 and down 75. So from the XY line, you can see here, I'm just using the 10 as a guide just to visualize it in the way here. So from the 10, I'm going to go up and down. Okay, so it's up 70, down 75. So from 10 up as far as 17, there's my little mark, and down 75, there's 70, 75. And there's my marks. Now what I would often do here then is I would actually plot those. So there's D and D. So take your time. Accuracy is actually quite key in this question. Next one then is the 130, so it's B, so it's up 20 and down 30 at the next one. So using my set square again, just using my 10 as my guide. So from 10 up 20 will bring me as far as 12, and down 30 brings me back to the 7. So there's my mark and my mark, and that is B. Don't worry, okay, if your lines go through it. Next one then is at the 160, so that's A, so it's 0 and down 95, so I'll actually just have to go down for this one and mark it there at the 95. So 95 down, so there is A, and I've got A here sitting on the ground. Mark it there like that. So there's my A. And then next one then is 190, so it's up 105, down 10. So for this one actually, up 105, down 10. So from the 5, up 100 will bring me as far as 15. 15.5 is 105. And down 10. That was the 190 mark, and that's E. And E. And finally the last one then, this is letter C, up 40, down 50. So same thing, from the 10, up 40, down 50. There we go. And that is C. So, what I'm going to do, just refer back to the picture here, just so I can see what I'm heaving in my details. Okay, so bear with me. So all heavy here, and then we have a heading detail line there and there. So CDE is the top one. That's fine. So I'll come back here. So let's start plotting those. So A connects to B, B connects to C, C connects back to A. That's my first planar surface, or my first lambda. Then we've got BCD, BCD, and then finally CDE and CDE. Okay, so there we go. ABC, BCD, CDE. Same thing down here. Okay, A is touching, so ABC. Put it in lightly to start off. And then I've got BCD. And finally CDE. Oh, good lord, apologies there, I'm after making a tiny error. There was my A, ABC. Apologies, mix it up. That was ABC. Then I got C, CD, what was it, ABC? And then I've got BCD, and then finally CDE. There you go. Apologies, after about 2 lines there. See how easy it is to make a mistake? So just about this line here, and this one. It's my bad. There we go. Okay, I'm going to heavy in some details here now, just so it stands out a little bit clearer for us. So in elevation, from A to B and B to C, same thing here. And same thing up here. Okay, there's our first 3 planes in the elevation. Now I'm going to do them in the plan. The one that I can see on top is CDE, so that will go in heavy here. C to D to E. That is fully visible in the plan view because that's the highest surface, as we can determine by the points in the elevation. Okay, the next one then is CBD. So I've got CB to D, so B to D. There's a heavy line. This line here from C to B, we'll go heavy there. Hidden detail in here. And then I've got ABC. So A to C is fully visible, there's nothing obstructing it. And then I've got A to B, which will be visible to there, but then the other planes are obstructing it in the plan view. And there we go. So there is our elevation plan completed, outside of a tiny error by me at the start. There's our XY line. Okay, part A of the question done. If we look back out here, is that what I've drawn? Yes, it is. So there we go, part A of the question done. To draw the given elevation and plan of the planes ABC, BCD and CDE just by using the coordinates supplied. Now what we have to do is we have to determine the dihedral angle between the planes ABC and BCD. So anytime you're doing the dihedral angle, what you need to do, okay, we have to get the dihedral angle between ABC and BCD. So I'm just going to use a little colour here. Just find the little colour that I have there. Bear with me now. If I can find the one that I want. There it is. So I've got 2 triangles here, ABC and then I've got BCD. So ABC, I'm going to colour it in orange there, nice and quick. I'll come back afterwards at the end of the question. But it does help us just in regards to our visualization. So ABC, I'm after colouring in there orange. That's my first plane. And the plane that I want to get a dihedral angle to show the angle between the 2 surfaces is BCD. Okay, so here's BCD, which I'm going to colour in blue. Okay, just colour on the outside. So there's my blue surface. Nice and quick now. Okay. Now, this will become a little bit more clear once I've shaded in the plan. By all means, fast forward. So there's the elevation done. Now, looking down on top of it, BCD, which is this guy here. I'm going to colour in this guy. Now, the reason I'm not going to colour in the whole thing is because the triangle CDE is actually sitting on top of it. Okay, so that's as much of that one. And then the blue one is on top of the orange one here, which is the ABC one. But I can see this edge of the ABC one down here. So we can see here, that is our plan view of the two triangles. Now, anytime we're getting the dihedral angle, what we have to first of all determine is, do we have the line of intersection? If you don't, you have to go and make one. But if you already have one, then fantastic. That's part of the work already done for us. So we've got two intersecting planes here. One is ABC, the other one is BCD. ABC, BCD. Is there any common line between those two intersecting planes? Yes, there clearly is. The line there, and I'm going to highlight it here in green. The line BC is my line of intersection. So I like that there. And I've got the line here BC, once again, which I'm going to highlight, is my line of intersection. That's my line of intersection there. Okay? Now the rule of thumb here is, when you're getting the dihedral angle, identify your line of intersection. If you don't have it, you have to go and find it. But because we have it here, then the next step is find it and determine if it's a true length. Now BC in elevation is not a horizontal line, therefore the line in plan is not a true length. Likewise in plan it's not horizontal, therefore it's not a true length in elevation. So the only way we can make it a true length is by taking, well, there's a couple of ways, but the way we're going to do is we're going to take an auxiliary view looking perpendicular to the line. Okay, so we're going to take an auxiliary view looking perpendicular to the line. And based off of this guy here, I'm just thinking, based on the room that I have, B, C, D, I'm going to take a view looking down here, like this. Okay, so I'm going to set up an auxiliary view. So projecting perpendicular to the line BC, I'm going to set up my x1, y1, just around here. I'm going to set up my x1, y1, my auxiliary view. I'm going to call that x1, y1, and I project the points perpendicular to it, A, B, C, and D. So there's C, comes down, there's A, there's B, and finally D. Now we know this, normal rule of thumb, if you project on the plan, take your heights from the elevation. So using your compass here now, I'm going to take my heights from the elevation. Now really easy one straight away, A is on the XY line, therefore A1, I'm actually going to label it there like that, and I'll just relabel this guy as A. A1 is sitting on my x1, y1. Now the next height I'm going to take is the height for B, so from the XY line up, as far as B, take that height with your compass, find B, out as far as the x1, y1, mark out the height. Next height I have is for C, I'm hoping this will just fit on the page. There's C, follow C out, lovely, and finally D. There's the height for D, mark D out, just fitting on my page as you can see. So I'm going to label all those points now. So there is B1, D1 and C1. Let's join them up. A connects to B, B connects to C, and this is just another view of our two intersecting planes ABC, BCD, but more importantly this one shows the line of intersection, the line BC, as a true length. Okay, once again, just go over now with my marker, just for demonstration purposes in the video. Okay. And once again, just going to use my colours. So ABC is the orange triangle, which is this guy. Just colouring that in there. Okay, and then I've got the blue triangle, BCD. Okay. So these are the two triangles I'm just focusing on here, because they're the ones that they asked us to get the dihedral angle between. And once again, just to move there, get the lights back on the room, guys. Apologies. Okay. Now that I have that done, that is my first auxiliary view. What I've done here technically is an auxiliary elevation because the heights are taken from the elevation. I'm going to highlight the line BC, or B1C1 in this case. That line is really important because that is my LOI as a true length, my line of intersection. Actually write it in. Line of intersection. I'm going to write here true length. Now, rule of thumb, if you have a true length line and it's sitting on a surface, if you look along the true length, you'll see the point view of that line. But if the true length is on a surface, in this case it's on surface both ABC and BCD, you'll then see those surfaces as edge views. So we're going to take a view looking along the line of intersection, okay, and project the points perpendicular then. Okay, so setting up, I'm going to look along the line of intersection. I'm going to set up a second auxiliary perpendicular to the line of intersection and keep it out here so I can keep it neat and tidy. Out there I think is okay. I'm going to call that an X2, Y2 and rotate. So BC will project out, and let's go a little bit further maybe. A is going to project out, and D. Okay, now rule of thumb here, how do you get the points? Then we take our measurements from the previous view back. So from the previous XY line, which in this case was the X1, Y1, I'm going to take it back. Now you can see here I have the tiniest little gap there. I'm going to get points B and C first, and watch this, from the X1, Y1 back to C, you'll see that distance there that I've marked. That should be the same distance from the X1, Y1 back to B, and you can clearly see that it is. Therefore, when I project out B and C, they will both be seen as what's known as a point view. So that there now is going to be called B2, C2, but a point view. So I'm seeing a point view of my line of intersection. Now I have to get two more points. The other one is D, really small distance here. So there we go, mark it out. And then the last one is A, and I can't even use my compass for that, it's so small, so I'm actually going to have to measure it and take the distance from here to here. And for me there, it's actually reading about 1.5 millimeters. So from A, go out to your X2, Y2, I'm going to mark out 1.5 millimeters. There's my mark. I'm going to label those. That one is D2, that one is A2. I'm going to draw it in. So that is the edge view of the triangle BCD, and here is the edge view of the triangle ABC. But more importantly, we now see the two of them as edge views. So ABC was orange, just going to go over that now in orange, as best I can. Go over this guy in blue, so I'm seeing those triangles. Okay, now that I've got that, that is part B done. Now, waste a little bit of time with all the colouring, just for demo purpose in the video. That is my dihedral angle inside there. Dihedral angle. Now, on the day of a test, you come along with your protractor, and you should measure the angle. So I'm going to measure the angle here now, see what we get. I'm measuring that there. For me, that's saying, measuring up to 0. 60, 70, it's saying about 75, 76 degrees. So I'm getting there, dihedral angle, I'm going to say 76 degrees. That's what I'm getting. Okay. So there you have it, folks. That there is part B of that question. Okay, I kind of squeezed it into the page here. I'm sure I could have done it a little bit neater. You'd have an A2 sheet on the day, but absolutely fine. Okay, so there's part B of the question done. Part C, determine the true shape of surface CDE. Okay, different ways you can go about it. So they want us to get the true shape of this surface here, C to D to E. Sorry, this surface up here, apologies. So the white surface, CDE there. Okay, they want us to get the true shape of that surface. So, first of all, when we're getting the true shape of the surface, often we can use what's known as a true length line on the surface. And is any of those lines a true length? C to D, D to E, and E to C. None of them are horizontal lines in elevation, therefore none of them are true lengths in plan. Likewise in plan, it's the same principle. None of them are horizontal, no true lengths in elevation. So we can make a true length on the surface. And to do that, we're going to use a horizontal cut, usually done from the middle point. So from D, I'm going to project across horizontal line until it intersects the edge on the opposite side, which is the edge from E to C. Where it intersects there, I'm going to drop that down to my plan. And I'm going to find where it is in plan. Okay, on that line there, I'm actually going to highlight it a different colour now. I'll go with a yellow. Find my yellow. That line I'm after finding. Okay, that yellow line is a horizontal line elevation. As I told you, we drop it, where it hits the edge or intersects the edge from C to E, drop it down, I find that in plan, and I connect it back to D in plan as well. So D is down here. But more importantly, now that I've got that line, I'm highlighting yellow once again. There's the line in yellow. What's important about that line is that line there in plan is now a true length. And as I said previously, if you look along a true length that's on a surface, you will then see that surface as an edge view. So, these principles come up all over the place. So now we're going to take a view looking along the true length line that's on the surface CDE. So, perpendicular to that true length, I'm going to set up another auxiliary. So, here's my next auxiliary. I'm going to keep it a little bit outside it, to keep it a little bit neater this time. I'm going to call that another X1, Y1. I'm going to project out the points, C, D and E. So C comes out, D will come out, and E will come out. Okay, project from the plan, because this is our plan. We're going to take our heights from the elevation, starting with C, from the XY line up as far as C. There's C, out to the X1, Y1, mark it. Now what should have happened here is that the 3 points should appear as a straight line. Little hint, what I often tell my students is only get the lowest point, which in this case is C, and the highest point, and D should be along that. Now, for the purpose of the video, I'm going to try and see, can I get them all perfectly in line? There's E. I'm going to mark out E. Actually need to extend my line a little bit further. There we go. And there's my points. So this is going to be C1, E1, and that should be D1. So I'm going to join C to E1, and I'm going to see if it goes through this point here. A little bit of inaccuracy there. Not bad. Tiny bit out, but a half mil out. I'll take that though. Okay. C1, D1, and E1. Okay. I'm going to heavy that in. There's my point. Okay, so that is an edge view of the triangle CDE. Now, what it's also showing is the inclination of the surface in respect of the horizontal plane here as well, okay, if they ever asked you for that question. Now what they've asked us though for is, they've asked us to determine the true shape of surface CDE. Now there's two ways we could do it here. From here, we could rabat the surface down. I could rabat points D and E down and then project them back and find it here. But I think the easiest way is just to take a second auxiliary. Okay, so if I take a view looking perpendicular to the edge view, I will then see the true shape. So I'm going to take my second auxiliary out here. So here we go. Quite a distance, it's a large distance back, so hopefully this will fit in the page. So I'm taking a view looking perpendicular to it. So this here now is going to be my x2, y2. Slips there now. I'm going to project out my points then, perpendicular. So here we go. C will come out. D and D. Okay, let's find the points. Where do I take my measurements from? The previous XY line back. In this case, the X1, Y1. I'm going to see if I can actually fit it. Otherwise, I'll have to use a data line. So I'm going to go out to the furthest one in this case, which is D. That's the one for D. D is in the middle. Is it going to fit in my page? Just fitting. Okay, I'm going to do it for E. And there's E, I marked from the X2, Y2, and finally C. And there's C. Okay, so there we go. Let's label. That's C2. I've got D2 up here and E2 out here. Now, just, and I mean just fitting on the page, literally using every part of the page as I can. So from there to there. Now I could have put in a datum line, keep it a little bit neater on the page. There we go. And there is my true shape of surface CDE. I did it by doing two auxiliaries. There is other ways you can do it, using rebatment, especially once you got to this point. Or you could identify technically 4 true lengths of the lines. You could find the true lengths of each of these, okay, by using rotation, and then draw it somewhere separately on your sheet is absolutely fine as well. But for the examiners, I'll write in there, true shape. So there we have it, guys. That there is part C of the question done. Part A was drawing the elevation and plan, part B was determining the dihedral angle, and part C was getting the true length of surface CDE. Okay, where we drew a horizontal line by doing a horizontal cut to intersect the opposite edge here from C to E, brought it down, located that line then, which becomes a true length, and if you look along a true length on a surface, you'll see that surface as an edge view. Then we take a view looking perpendicular to that surface, the edge view, and that will then determine its true shape. Okay, last part of the question here. What we're going to do now is we are going to determine the horizontal and vertical traces of the plane ABC. Okay, so plane ABC, we have to get the VTH of the plane ABC. So ABC is my orange plane here. Now what's really helpful here straight away is I'm actually going to find my horizontal trace first, and then I'm going to find my vertical trace. The reason I'm going to find the horizontal trace is because technically point A is already on the ground. Because point A is already on the ground, point A in plan has to be a point on my horizontal trace. So that there is actually a key point. That is on the horizontal trace. Now what I want to do is I want to find a second point so I can actually draw in the trace. So to find a second point, what I'm actually going to do here is I'm going to extend the surface CB until it hits the XY line. So where's CB? I'm going to extend out CB until it hits the XY line. And it hits it all the way over here. So, a T-square there. I'll just extend out my XY line. That's where it hits it right there. Now, I want to find the second point on that trace. Likewise here, I'm going to do the exact same thing. I'm going to extend CB out, like I did in elevation. I'm going to extend CB out like that, and where this one hit the ground, that has to be a point on the horizontal trace in elevation. So how do I find it in plan then? Drop it down. There is my second point on my trace. So that's my first point, which was point A. This is my second point. Now I can actually draw in my horizontal trace. So A had to be on it because A is already on the ground. Here we go. That there, nice and big. That there is my HT, my horizontal trace. HT. Now, I'll highlight it in red in a minute. now I have to find my vertical trace. So how do I find my vertical trace? Well, I can use any of these points, A, B, C. I won't use A, I'm going to use point C. So actually I'll use B as an example. So the method here is, if you go parallel in plan to the horizontal trace, which I already have, parallel to HT in plan, I'm going to do it from point B. Let's go parallel where it hits the XY line. So that there is parallel to that. Where it hits the XY line, I'm going to bring it up vertically and then project B out. And that point there has to be a point on my vertical trace. Same method would apply if I was to do it from C. You'd get another point over there. No need, I found it. Let's draw it in. And there we go. That is our VTH, that is our oblique plane for the surface ABC. They haven't asked us any about the other surface BCD or CDE. They've only asked us for the vertical and horizontal traces of the plane ABC. Okay, so just using the highlighter there, I like to make them stand out. Okay, there you have it, folks. That there was the 2025 Leaving Cert question for the intersecting planes and oblique plane topic. Quite a nice question actually. It's probably one of the nice ones that has come up in years. If you're well kind of rehearsed in that. I was just plotting coordinates, standard then getting a dihedral angle. Now I kept it quite tight inside here, obviously on the day of an exam. You'd probably have it spaced out a little bit better than I've done it, just for the purpose of fitting it on the A3 sheet. And then we had to get the true shape. And then we had to get the traces. All common things that you should have covered in your syllabus. Hope you found that helpful.